Hello, PERL folks. We are covering subroutines this week. Chapter 8 does cover, has good coverage on subroutines, argument list, and returning values. No need to go past page 260 in the ebook. We're going to talk about references later. We're doing random generation also, and you can get most of the material from the class notes on this one. And we're going to talk a little bit about scope, because that's important in subroutines, and you can also find a pretty good coverage of that in chapter 8. One exercise and one expert corner on basic authentication. This is an important part of the class. So let's go right to the class notes. Functions and subroutines. Functions, think of them, I guess, mostly as PERL built-in. It's the PERL terminology anyway. Subroutines are the ones that we create ourselves, and that's pretty much the same thing. Reasons for doing subroutines and functions. One of them, of course, is if any specific lines of code need to be repeated several times in the program, then it's a good thing to encapsulate them in a subroutine. But mostly, if you have any more than 10 lines of code, then it's a good idea usually to categorize those into one piece of code as a subroutine, and it makes your program more legible, more easy to recognize. For instance, if you had a program such as this, you usually have some setup at the beginning of the program. You have some input. You're going to process information, and you're going to output it. So at a glance, someone can look at your entire program and get a pretty good idea what it's going to be about. If you're interested in more details, you can always go down below and look at the definition of the subroutine itself and look at the details. There are three ways of calling a subroutine. One is to just use parentheses. If you have parentheses, even if they're blank. Parentheses in subroutines and functions usually are for values that you want to pass to the routine. But if in PERL has no way of knowing that this is a subroutine unless it has parentheses on the right or an ampersand on the left or both. The ampersand is a nice way to go because it's very consistent with PERL, right? We have dollar signs or @ signs or percents that make your variables give your variable a different type. So here we're calling a routine 3 times, and here's a routine definition. We start with sub, we name it. Note that there's no parentheses there at all in the definition of a subroutine or a function. That's because, as we'll see later, a routine retrieves the data that is sent to them with a special array automatically. So we don't need to define any variables right here. So let's see this. We should see print hello from the subroutine 3 times. Here we go. Hello from subroutine 3 times. Now, passing values to a subroutine. In the parentheses, you simply pass a list of all the values you intend on passing the subroutine. So here we're passing to display 1, 2, 3, and 3 values. In the definition display, note that we have a new variable here. This is a special variable, a special array variable, just like the special dollar sign underscore variable. Anything that's being passed to a function is simply put in a list and using the special variable at underscore. So we all know how to get information from an array. So if we're interested in getting information into our function, all we have to do is get information from the array. In this case, we just use the standard join. You should remember that a join function transforms an array into a string, and every element in the array becomes separated by the character that we specify right here. So let's go ahead and run that. And here we go. The string is now 1, 2, 3, 1, 2, 3. We have received data into our function. Next, we need to learn how to return a value from a subroutines. In this case, we're putting Paul into first, Jones into last. And notice that we have a routine here called concat, and we're going to pass Paul and Jones. And this function happens to be on the right side of an equal sign. Therefore, we expect this subroutine to return information, and specifically, we must be returning 3 things, or at least 3 things, because we are capturing those 3 items in a list of variables: full name, first name, last name. And then we can just let's see, then we're going to print full name, first name, and last name just to make sure that it works. Let's take a look at the definition from concat. Here's our special array variable, and we're going to capture 2 pieces of data, right, from first and last. We're into variables dummy variable 1, dummy variable 2. Now we can process information, and we're going to simply concatenate the first name to a space and finally the last name. Remember, the period is a concatenating operator. We're putting that in D3, and we use the term return. Unlike some other languages, Perl will let you return as many items as you want. So yes, we are returning 3 pieces of data, dummy 3 being first, and that's going to be captured by full name, D1 captured by first name, and so forth. So we are returning these values, and we're going to print them just to make sure that is true. And here it is: full name, Paul space Jones. Careful when passing a mix of arrays and scalars. The special variable is set to flatten arrays and hashes. Example: we have an array here, 1, 2, 3, and we have a scalar with 4. Try to pass the array and the scalar in this manner, and it will not work, because as you know, the array variable, the special variable, simply grabs all this information as a list. It doesn't differentiate between what part of the list belongs to the array and what part of the list belongs to the scalars. It will flatten all the information inside the parentheses. So here we go, we may attempt to reconstruct this data into an array and into a scalar, but it will not work. All the data will be dumped directly in the array, since this is expecting a list anyway. So this is a list. It will go directly in D1. D2 will be left with nothing. And if you try to reverse the process, what are you going to get? Of course, you're going to get 1, because that's the first item in the list, and then the array following is going to get the rest. And D1 has everything, D2 has nothing, D1 has 1, and D1 has the rest. Very good. Pass data in hash format if we don't want to remember the order of the parameters. That's good. Notice that we can pass this type of data, which is nothing but pairs, right? For a hash definition. We have a key followed by the data. Key, data. In name we have gen40. In password we have this value, and the host name has server. So we create keys and we pass that to our function or subroutine. Now, as you know, this will be a list. It's very much like dumping an array into a hash, isn't it? Here we're going to, first of all, print a debug statement with our special array variable by using the join function once again. And here's an interesting error execution here. Die parameters to log on should be even if, this is the command, the if statement after the statement, if the special array modulus by 2 is true, meaning if it's not even, this should be item 0, item 1, item 2, item 3, item 4, and item 1, 2, 3, 4, 5, and 6. These are 6 items in the special array, and if you do a modulus by 2, then everything will be fine as far as transferring this data to a hash. Otherwise, it will not work, and your program should kill. So now we are ready to take the 6 elements, or the even number of elements in this array, and populate the hash immediately. Now you're ready to just use the hash as normally. This is the $sign for one item of this hash. We know it's a hash because it's got the braces. This is a key, which now should be available, and we're going to get the value of that key, which should be server 1. And here it is, server 1. And this is the dump of the special array. Returning list into scalars. Well, yes, we can do this quickly. Here we have again, this function must be returning data, in this case 2 pieces of data, and yes, it's returning Sue and Smith, but you can also return this data into an array. Since it is a list after all, we're returning 2 pieces of data, we can just as well use an array on the left side to capture that data. We can also return either a scalar or an array. This is similar to, this is the concept of an overload in most languages. We have an easy way to do this in Perl. We can make one routine, and depending on its context, it will return either a list or it will return a scalar, depending on, and meaning by its context, meaning what variable is on the left side of the assignment. Is it an array or is it a scalar? And so we're going to use the function for this is called wantArray. This is a Perl function, and this function will sense if the function is used on the right side of an array or a scalar. And if it's an array on the left side, then this will be true, and in this case it will return a list. Otherwise, it will return only one thing. This is, you see a lot of functions and subroutines in Perl which have 2 purposes. For instance, if you use the date function, you'll notice you get a different result if you dump the content of date into an array or a scalar. Another Perl shortcut quickly. We have 1, 2, 3, 4, 5, 6. You can take your special variable and put this in the for each all on the same line on the right side of this incrementation here for total. Another one, you can create this if valid, make it very simple. Print a valid number. If is valid, pass your number, and look at this. You can just use shift. This is a very quick way of getting the first item out of your special array out. And even if you have 3 of them, in this case we only have 1, but if you have 3, just go shift, shift, shift. Just keep on shifting and grab all your data into variables inside of your function in order to use them. Random generator. This is the random function, and it will returns a float between 0 and slightly less than 1. If you put an argument such as 6, you get a floating point from 0 to slightly less than 6. So the way it's usually used, you put 1 if you're not interested in the 0. You say 1 plus the integer of, and then you issue that statement there. It will give you integers between 1 and 6. We're going to, our example is going to be rolling a die. And we're setting this function up so that we get a number between 1 and 6. And we're going to print it just to make sure. We're also setting up a couple other ones here without the function R and R2. And we're going to print all 3 of them. Here's our roll die function. It returns, yes, the calculation directly. 1 plus integer random 6. Let's try this out. And the die is 3, the first one. This is the function call. And here the other 2, R and R2. One is 3, and well, they all turned out to be 3, didn't they? Or is it 3, 1, 3? I think it is. Okay, let's run it again. 3, 1, 6. One more time, please. 2, 1, 1. Yes, okay, well, at any rate, it should be a fairly random number. Random function needs seeds. So this is the other concept we need to, every programmer needs to learn that. A seed, every random generated number in a computer has to start from a seed. It starts from a number, puts this number through some kind of algorithm, which is not all that complicated, and comes up with a number. By default, Perl uses a system clock as a seed, which is good because you basically get a new number every 100th of a second. But you can also provide a seed, and you use the command sran. Now, a seed will return predictable random numbers. It's important to understand that. If you send a seed of 2 and then produce 3 random numbers, those random numbers will always be the same. So let's test this out. And so get these numbers, right? 467, 294. We're going to run it again with the same seeds, and the random numbers should be identical. Here it is, 467, 294. Please understand this concept. We don't have time here to cover it too much longer than that. But we can talk about it on the board if you're interested in more talk. We had a good conversation in class about that. Here's a game of craps. A player rolls 2 dice. Each die has 6 faces, as we know. These faces have 1 through 6 spots. When they come to a rest, we calculate the sum. And if the sum is 7 or 11 on the first throw, then the player wins. If the sum is 2, 3, or 12 on the first row, then it's called craps. The player loses, or the house wins. If the sum is 4, 5, 6, 8, 9, or 10 on the first throw, then the sum becomes the player's points. And then to win those points, the player has to has to match these points on the subsequent throw. But if they roll a 7, then they lose. Okay, this is a nice little example. We're going to simulate this game, and we have this time a routine called roll dice. Note that we can use this function we already have called roll die twice in a list. It has to be in parentheses. It has to be a list here on the right side. Roll die, and we're going to capture both of those random generators numbers in die 1 and die 2. We get our sum, and we can the program can give us the feedback and figure out what we got, and then return sum. Okay, so here we are using this function on the right side of this assignment, and roll is going to contain our sum. If roll equals 7 or 11, then we capture this string in the status, because we can either win, lose, or continue. So in this case, status is going to contain 1. Else if, notice how else if, and don't forget the else if is written strangely in Perl. If the roll is equal to 2 or 3 or 12, then the status becomes lost. Finally, in any other condition, status will be continue, the player points will be the sum, and again our program is going to let us know what's happening. Now we go into a while loop, and the status of course is going to be as long as equal continue. Don't forget EQ is the equality for strings. And so in this while loop we roll the dice again, get ourselves a sum. If the sum is equal to player points, then we can change the status to 1, in which case the while loop will no longer be satisfied and it will fall through. Otherwise, the else if is 7, then the status becomes lost, it's no longer continue, and it falls through. Otherwise, status continues to be continue, and it keeps rolling here until one or the other. And falls through the while loop, goes through the print, calls the subroutine called message, and we call it the status. We pass the status onto the function. Here's the definition for message. Here we're using the shift, and remember that you don't even need to put the rest of the information. We only have one piece of data here. Why not just shift? And that's the status. Now, and also notice, we're going to talk about that soon, we have a my. That means that this variable status is defined only within this function. This is called a lexical variable. This variable has nothing to do with this one. This one is global. It's available everywhere in the program, but as soon as you reuse the same variable name inside of a block, right, or a function, if you put the my in front, then this becomes its own variable which only exists within the block. We'll talk about that in a minute. So status now has the same data as this one, and it's explained here, private, and then we can say return darn if status equals lost, or return wow. Okay, so let's do it. Let's play the game a couple times. Let's see how lucky we are today. Ooh, well, not too lucky. I rolled a 6 and a 3, which is 9, right? And I was trying to get a 9, but I sure got a 7. Okay, let's try it again. Oh, the luck is really smiling on me today. Well, okay, we'll take that one. Roll 3 and 4. Okay. Next, we need to talk about scope. Scope is the visibility of a variable within a running program, just what we just looked at. There are 3 terms here: global, lexical, dynamic. These variables are visible to the entire program, and if the way we've used variables so far is to just ignore putting these either our, my, or local in front, and that makes it global by default. But you can also say our, and you know for sure this variable will be visible anywhere in the program. If you say my in the definition or declaration of the variable, it becomes a lexical variable, a funny name here, which only exist within the block in which they are declared. But then the local variable, which I believe is used in other languages to mean lexical, but in Perl, local is it's a dynamic variable because it's active from its declaration to the end of its block's existence. So in other words, if one routine calls another, then the variable in the first routine follows in the routine that's called. So this local here variable goes a lot further than this one. The my only exists in the block in which it is described. Quick example. Well, I'll let you folks look at the example, but it's pretty clear here that you have x and y defined as global. You're going to be calling some routines here, and these routines also have their own x and y. And notice we're going to change the values of these. We have a ma here, we have a local, slightly different flavors of scope, and we change their values in these different subroutines, and you just run this program and see the result. And notice that when you go back into main, you can still use y and x, and you wonder what values they contain after all these different manipulations. Okay, thank you very much. We're done.